Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. So here we start with the first question. It says, what happens as ice melts at 0 degrees Celsius? So we have three options. We have to identify which options are correct. The first one, molecules gain kinetic energy and temperature increases. The thing is, when ice starts melting, what happens is temperature does not increase. Temperature starts to increase when all of the ice has melted, right? So with this much information, I can eliminate option one. And if I eliminate option one, just by looking at the option, I know that the correct option should be C. But let's check the other two options. So the second option says added energy overcomes hydrogen bond between the molecules. This is true because if you add energy, what happens is your bonds start to break. In this case, there are two types of bond. You have the bond between the oxygen and hydrogen, and the second type of bond is the hydrogen bonding present between the molecules. Now, the oxygen hydrogen bond enthalpy is too much, so this much energy won't be enough to basically break those bonds. But this much energy is enough to break the hydrogen bonds between the molecules. This one is right, of course. Now the third one, molecules gain sufficient energy to move from fixed positions. This is also right. So what's the logic behind it? So whenever ice melts, what happens? The conversion is from solids to liquids. So in a solid particle, in solids basically, particles are present in fixed positions, but in liquids, particles can move. So the third option is also right. So from this, we can say that option C is the correct answer to this question. Moving on to the second question. So here we have this mass spectrum. It says that there's a compound with empirical formula CH2. Now we have to identify which compound they're talking about. Now here just if you just observe the options, you'll see that all of the options, like if you just simplify, all of them have an empirical formula of CH2. So this information is not much of our use, right? But if so, what we have to do is we just have to look at the mass spectrum and identify the highest peak or the biggest peak on the extreme right, so which is in this case 70. Please do know, we'll find this is 70, right? So what we have to check is we have to check which molecule has a molar mass of 70, and that will be our answer. So the first one, C2H4. C2H4, if I find the molar mass, carbon is 12, so 2 times 12, and hydrogen is 1, so 4 times 1 is 28. Wrong. C3H6, 3 times 12 plus 6 times 1. So 3 times 36, 36 plus 6 is 42. C4H8, 4 times 12 plus 8 times 1. 48 plus 8 is 56. So the last one, 5 times 12 plus 10 times 1. 5 times 12 is 60, 60 plus 10 is 70. So from this, I can see that for the last one, our molecular mass exactly matches with the with the m by z ratio of the highest peak at the extreme end. So our option D would be the correct answer to this question. Now moving on to question 3. So this is a good stoichiometry question. So what species are present after 15 meter dm cube of buta-1,3-diene has reacted with 18 dm cube of hydrogen to produce butane? So for this question, we can use a specific strategy. So for our stoichiometric ratios, if instead of stoichiometric ratio, if all of our reactants or products are gases, we can use volume ratios. They work exactly the same as stoichiometric ratios, right? So first I can do V by SC to find the limiting reactant. So I know the volume of butadiene, buta-1,3-diene, and I also know the volume of hydrogen. So V by SC of butadiene, okay, CH2, CH, CH, CH2. This will be 15 is the volume. Stoichiometric coefficient of butadiene is 1, so this is 15. And then if I find the V by SC of H2, this will be 18 divided by 2, which is 9. So basically, V by SC of H2 is smaller than the V by SC of butadiene. So from here, I can say that H2 is our limiting reactant. H2 is the limiting reactant. That means what? Basically, like at the end of the reaction, all of the hydrogen will get used up, and what we will be left is butadiene and your product butane. Okay? So from with this, I can eliminate option A, I can eliminate option C, but I still have option B and C where butadiene and butane are present. So I have to now find out the volume of butane or volume of butadiene, any one of them. I'll just find the volume of butane because that's easier. So yeah. So to find the volume of butane, what I'll do is I'll write the volume ratio. So volume of butane, yeah, by volume of H2. Now, after finding the limiting reactant, we'll always use the limiting reactant as our basis of calculation, because I know that all of the limiting reactant would be reacting in the reaction. So this will be 1 by 2. So volume of butane produced, this will be equal to volume of H2 divided by 2. Volume of H2 is 18, 18 divided by 2. Basically 9 dm cube of butane will be produced. So here if I look at the options, one has 18 dm cube of butane, which is wrong. Other one has 9. So I can say that option B is the right answer to this question. Now that's all about this. Now moving on to question 4. So question 4 is about the electron transition that corresponds to red line in hydrogen emission spectrum. It says emission spectrum, right? Not absorption. Now here you have these options. So first I can eliminate out option C, because option C corresponds to absorption spectrum. If an electron absorbs energy, then only it jumps from lower energy to higher energy shells. If an electron emits a photon, then it will be coming from a higher energy, like a higher shell to a lower shell basically. Now it says red line. Okay. Now red line has the longest wavelength in the visible spectrum. So yeah, just writing it down. Has the longest wavelength. And longest wavelength means lowest energy. Why? Because E is equal to hc by lambda, right? If you have a very big wavelength, very big value of lambda, your value of E will be the smallest. Now between A, B and D, we see that A, the energy transition is the least between 3 and 2, right? So I can say A is the correct answer to this question. And that's all about this one. We can move on to the next question. Now in question 5, it says which of the following can be used to identify the group of the element in the periodic table. So firstly, successive ionization energy will be able to give us an idea about the group of the element, because from here we can find the big jumps, and using the big jumps we can find out how many valence electrons are present, and with the valence electron information we can get the idea about the group of the element in the periodic table, right? Second is electron configuration. Obviously electronic configuration can be used. We can directly find the number of valence electrons and hence identify the group. Number of occupied energy levels. Now number 3, the third option might not be correct. This because number of occupied energy levels will give us the idea about the period, but a period can have multiple elements, right? So then all of these elements will have different groups. So it'll be it will be impossible for us to identify the group of the element just by looking at the occupied energy levels. So third one will be wrong. So answer will be 1 and 2 only, which is option A. Moving on to question 6, we have to find which element is an actinoid. To find an actinoid, we have to move to the periodic table given in the data booklet. So this is our data booklet. Now, and then the bottom two series, the bottom one is our actinoid series, the top one is the lanthanide series, right? So here, if you look, we have these elements here. Now we'll just have to check. Yeah, I think this PA is an actinoid. Let me just go here. So yeah, here you see PA, right? So hence, your answer will be option D. Now, which oxide produces an aqueous solution with highest pH? Highest pH means which one of them will produce a base, right? So Na2O. Na2O basically, while mixed with water, will give you NaOH, which is a base, which is a very strong base. So this gives us NaOH. P4O10 will give us an acid. Okay, it will kind of give somewhat like S3PO4. There's an acid, there's a base. Na2O will give us HNO3, HNO3, HNO2, which is also an acid. And CO2 will give us H2CO3, which is an acid. So acids have lower pH while bases have higher pH. So answer will be option A. Moving to the next one, we have to find the oxidation state of cobalt in this complex. We can find it easily. We can take the oxidation number of cobalt as X. Chlorine is a halogen. We'll take the oxidation number of chlorine as -1. NH3, it's not NH4, it's NH3. NH3 will have 0 oxidation number because it's a neutral compound, right? This will be equal to the net charge on this. If you can check here, it's -1. This equals -1. Now here we have to solve for X. X minus 4 equals -1. So X will be 4 minus 1. So finally X is +3. So answer will be +3, which is our option B. Moving to the next question. Yes. Which type of substance has the following properties? We should have high melting point. Okay, so high melting point means I can rule out simple molecular, because all simple molecular compounds have low melting points. Non-conductor of electricity as a liquid. Okay, if it's a non-conductor of electricity as liquids, I can rule out my metals, right? And even ionic compounds are conducts electricity as a liquid, so I can also rule out ionic. So from here I can say that just from this I can say it's D. Yes. And if it's giant molecular, I mean, we can say it's a non-polar compound, and hence it will be insoluble in polar solvents. That's fine. Now moving on to question 10, we have to find out which species have resonance structures. First, CH3, CH2, CH3, which is an alkene actually. So there are no lone pairs available which can actually move around this structure. So one will not have any resonance structure. So if we can just eliminate option 1, we can get option. I mean, we can find out that option C is the only possible answer here, right? But we can look into the other options. O3 actually looks like this. So how does the resonance work? Basically, the electrons will come here while the double bond here will open up, and this will be the other resonating structure. Here there will be a positive on this oxygen, hence the net charge is 0. So these are the two resonating structure of of your ozone O3. For NO3 minus, the structure looks like this. This is your NO3 minus. Okay, and there's a positive charge on nitrogen. Now what happens is this electron can come here and it can form a resonating structure. Okay, and then the other one is like these electrons can come here and this bond can open up, giving you the last resonance structure. Minus, this is 1, and this is the other oxygen. Nitrogen will have a plus. So obviously 2 and 3 will show resonating structure, and C is the right answer. Now which of the combination best describes NO2 minus? So we can use our formula to solve this question. So first, number of electron pairs or electron domains around the central atom nitrogen. We can find it using this formula, half times number of valence electrons in nitrogen, which is 5. Right, plus any positive charges in the molecule, plus 1, minus any plus any negative charges, sorry, and minus any positive charges, plus any monovalent atoms attached to this compound, which is also 0 because oxygen is divalent. So yes, so this is 3. So the first part is the number of electron domains around N is 3. So we can eliminate option A and option D with this information, right? Now NO2 minus, we have to find the number of lone pairs. Number of lone pairs is number of electron pairs around N minus the number of atoms around N. In this compound we have two oxygen atoms around, so lone pairs is 1. Right. So if it's 1 lone pair and it's 3, so if the electron geometry is 3, right, if you have 3 electron pairs around the central atom, your electron geometry would be trigonal planar. In this trigonal planar, we will replace one of the groups with lone pairs. So we will get something like this. Okay, it's NO2 minus, so probably will look like this, right? So when we draw the structure, we won't be able to look at this lone pair here, right? So it looks like a bent structure. So answer will be, I mean, obviously the molecular geometry will be bent. Now what would be the bond angle? Now bond angle will be a little less than the actual bond angle. If it was trigonal planar, the bond angle will be 120 degrees. But as you have a lone pair instead of one of the groups, what happens is there will be bond pair lone pair repulsions. As a result, this 120 degree will shrink a bit, but not too much. Okay, so the bond angle will probably be around 117 degree, because 105 degree will be a big decrease. 105 may be possible if you have like 2 lone pairs or more than that. And more than that won't be possible here. So yeah, it will be option C. Now moving to the next question. What is the molecular geometry of BrF5? Again, we can use our formula. Number of electron pairs around Br. This will be half. Number of valence electrons as Br is 7. There are no negative charges, no positive charges, but there are 7 monovalent fluorine atoms attached. So this will be 5. So 7 plus 5 is 12. 12 divided by 2 is 6. Okay. So number of lone pairs around Br. This will be number of electron pairs around Br minus the number of atoms surrounding Br. So this will be 1. So if you have 6 electron pairs, your electron geometry would be octahedral. And as your electron geometry is octahedral, you have to draw it out and replace one of the groups on the axial plane with electrons. So this is how it will look like. This is your equatorial plane, right? And your lone pair will be here, the axial plane. Now how does it look like? If you just connect all of them here and connect the base, you will see that it looks like a square pyramid. Okay, which is option C, which is a square based pyramidal. With this, we are done with this question. Moving on to the next one. Which gas contributed to ozone depletion? Ozone depletion, okay. Yeah. So ozone depletion is related to our free radical mechanism. Okay, and if you remember, like how we can answer this question in an exam is like, if you remember, the oxidation of NO to NO2 occurs through a free radical mechanism, which is mentioned in every textbook. So from there, we can say that the answer is option A. These are the points. So ozone depletion is related to free radical mechanism. And NO gets oxidized to NO2 by a free radical mechanism. So this is the way you can remember or answer this logically. Else, like, this is a complete question where you have to completely apply your memory to solve it. Now moving on to the next question. So how much heat in joules does a 2.2 gram block of copper at 65 degrees will lose when it's dropped into 100 centimeter cube of water and cools down to 15 degrees Celsius? Okay, alright. So initial temperature of copper is 65, final temperature is 15, right? This is done. So heat lost by copper would be MC T initial minus T final. We can also take minus MC delta T minus MC T F minus Ti, then put the negative inside, which will make it Ti minus Tf. Now we just have to plug in the values. Mass is 2, right? It is 0.385 and it will be 65 minus 15. If we just do this, our answer will be option A. And that's all about this question. Now moving to the next one. What is the correct formula for calculating enthalpy change of a reaction? Okay, so they have a number of options here. So if you have enthalpy of formation, it will be enthalpy formation of products minus reactants. We can eliminate option A. For enthalpy of combustion, it has to be enthalpy of summation of enthalpy of combustion of reactants minus products. B is also wrong. Now we are down to the bond enthalpies here, right? So for bond enthalpies, it is summation of delta H bonds broken minus summation of delta H bonds formed. Okay. Now we break all the bonds on the reactant side, we form all the bonds on the product side, right? So bonds broken is basically on the reactants, bonds formed is basically on the products, which gives us option C as the right answer to this question. Moving to the next one. Which change represents electron affinity? Electron affinity means addition of electron. Addition of electron, yes. So O2 to 2O, this is basically bond enthalpy. This is that the oxygen bonds got broken, right? O gives you O plus E minus. In this case, it's ionization energy because electron is removed from oxygen, not electron is added. Next one, O2O plus E gives you O2. Now this reaction is wrong because charges are not balanced on both sides. So basically, net sum of charges should be equal on the reactant and product side. But here it's not, so I have to eliminate option C. But in option D, it is basically the second electron affinity of oxygen, where O minus adds an electron to form O2 minus. So answer will be option D. Now next one. Which changes results in the greatest decrease in entropy? Decrease in entropy as in, like, your randomness decreases. So here, solid to aqueous, your randomness increases. So in this case, delta S will be positive. If you have a solid, the molecules are packed together. But if you have a liquid, the molecules are, you can say the ions are free to move, right? So obviously the randomness has increased. So here in the second option, your randomness has decreased. 2 moles of gas have been decreased to 1. delta N would be 1 final minus initial, 1 minus 2, which is minus 1. Okay, so this can be an answer, but we have to check the other options. For the last one, you have to, you can see that the number of moles of gas is increasing. Delta N would be, you have 4 moles of gas on the product side and 2 on the reactant side. So this is 2. So in this case, your entropy increases. So we can eliminate option D. So A and D has been eliminated. Now option C is, we have solid aqueous, which gives you aqueous and gas. So in this case, delta N will be, you have 1 gaseous mole on the product side but no gaseous moles on the reactant side. So here also you have a positive delta N. That means your entropy is increasing, or randomness is increasing, right? So I can also eliminate this, leaving option B as the correct answer. In option B, moles of gas are decreasing, so your randomness decreases. As a result, your entropy decreases. Moving to the next one. Which methods could be used to determine the rate of this reaction? Okay, alright. So in this reaction, H plus ions are formed. That means what? Your pH will be changing. Yes. If pH is changing, we can track the change in pH with time, how the pH is falling with time, and using that we can get the rate. So first one can be used to determine the rate of this reaction. Second is change in electrical conductivity. This one can also work, because you see ions are produced on the product side. So basically the solution will become more electrically conductive with time. So the conductivity changes with time. So second option can also be correct. Change in mass. Now in this reaction, no gases are produced. Everything is either liquid or aqueous. That means no mass will be able to escape the reaction mixture. As a result, change in mass cannot be used, as it will be constant throughout. So answer would be 1 and 2 only, which is option A. Moving to the next one. This is the question. Sodium thiosulfate reacts with excess HCl. This is your reaction. The dotted line represents mass of sulfur. So you have excess HCl. So yes, so this is the dotted line represents the mass of sulfur produced. Alright. Which line represents change in mass of sulfur per unit time when concentration of HCl is doubled? Okay. So HCl is the excess reactant, and sodium thiosulfate is the limiting reactant. You're not changing the mass of the limiting reactant, you're changing the mass of the excess reactant. That means what? The amount of product which is produced will remain the same. There will be no change in the amount of products produced, because your limiting reactant has the same mass as before, or same moles as before. So I can skip A and D, I can cancel these two out. But as you have more HCl, what happens is the reaction will be faster with time, right? So if you check B and C, C is the slower reaction, because you are achieving the same mass with a lot more time as compared to before. So before, if you check the dotted line, this was the time taken, and here this is the time taken for C to exactly produce that mass. So answer will be option B, because in option B you have the same mass produced, but this mass is produced faster as compared to the dotted line. This is also wrong. Okay, pretty common question. So here okay, so you see you're changing the concentration of CO, you're halving the concentration of CO, but this doesn't have any effect on the rate. So the rate is independent of CO. You can say rate is CO to the power of 0. In the next case, you are doubling NO. When NO2 concentration is doubled, okay, so you can see the change is 2x. The rate will be 5.6 times 10 to the power minus 5 divided by 1.4 times 10 to the power minus 5. So rate becomes 4 times. Yeah. So you're doubling NO2 while, so this is 2x. The rate is becoming 4x, right? So here you can say rate is directly proportional to NO2 whole squared. So this is the second order reaction. The overall order of the reaction will be C, which is 2. And that's it for this one. Now let's move on to the next question. Yeah, which statement is correct for the components of Arrhenius equation? EA decreases as temperature increases. This is wrong. Activation energy is independent of the temperature. It's only dependent on your catalyst. Whether if you're using a catalyst, activation energy will be lowered. If you're not, activation energy will be high. Second, A relates to the collision with current orientation. This is right, because A is also called the collision coefficient. What do you say, a catalyst or something, because obviously it requires more more energy for the reaction to proceed. That's why your reaction will become a little slower. Or you can even say that like K is independent. K is not dependent on temperature, not exactly on the activation energy, because activation energy remains constant. So C can be eliminated. D, K is independent of the temperature of the reaction. This is wrong. If you change the temperature, K will change. That is basically the main use of this Arrhenius equation. How your rate constant changes with temperature. Now, equilibrium constant of a reaction is given. You have to find the equilibrium constant of a different reaction. So basically, this reaction will be obtained if I flip our given reaction and multiply it with 2. If I flip my given reaction, the rate constant will become 1 by the previous value. And if I multiply it with 2, it will get squared. So 1 by 0.0059, this entire thing is under square. This will be 1 by 0.0059 whole squared. This is giving us option B as the right answer. Now moving to question 23. Yes, Kc of this equilibrium for the equilibrium between H2 and I2 is 51 and 720 degree. Which combination is correct? So basically at 720 degrees your equilibrium constant is greater, it is greater than 1, right? Greater than 1 means your products are favored. I can eliminate option C, option D. So Kc greater than 1, products are favored. Products are favored means the reaction is favored, and the reaction is favored when delta G is negative. Also eliminate this, option B is the right answer. Moving to question 24. Which two species can form a conjugate acid-base pair? Conjugate acid and conjugate base. So yeah, we can just pick out H3O plus and H2O. H3O plus H2O plus H plus. Okay. H3O plus is the acid because it donates or gives out if you look at the forward reaction, H3O plus is losing an H plus. Right? In the reverse reaction, H2O is accepting an H plus to form H2O plus. So this is the conjugate base. Right? So H3O plus H2 is the right answer. Now, which methods can be used to distinguish between HCl and HCOOH of equimolar concentrations? So this is pretty straightforward. The answer will be option C. HCl dissociates completely while methanoic acid dissociates partially. So in an HCl solution, you'll have more ions if you have equimolar concentrations. In the HCl solution, there'll be a lot more ions as compared to the methanoic acid solution. So if you have more ions, you'll have better electrical conductivity, and hence C is the right answer. Moving to question 26. At 298 kelvins, the pKa of ethanoic acid is this and pKa of chloroethanoic acid is this. Which statement is correct? So smaller pKa means better acid or stronger acid. The first one is wrong because pKa has a bigger, so just writing it here, smaller pKa means stronger acid. Okay. And smaller pKa means greater Ka, bigger value of Ka. Okay. So B can also be eliminated because the Ka value of ethanoic acid is greater than, this is wrong. pH of ethanoic acid is lower than pH of chloroethanoic acid because this is also wrong. Because if you have solutions with same concentrations, chloroethanoic acid is a better acid. So the pH will be lower for chloroethanoic acid, not ethanoic acid. And last is the ethanoid ion is stronger base than chloroethanoic acid. D is correct because ethanoic acid is a weaker acid. If it's a weaker acid, its conjugate base, which is ethanoid ion, will be stronger than the chloroethanoid ion of the stronger acid. So, yes. Moving to the next question, we have to find out which combination produces a buffer solution. So, what is the condition of a buffer solution? For a buffer solution, you should have acid and a salt. Both must be present in the solution. And this is only possible if the moles of NaOH is less than the moles of ethanoic acid. Just write it down. For buffer, both acid and salt must be present in the solution. Right. So our main condition to check is moles of NaOH must be less than moles of CH3COOH. Because if your moles of NaOH is greater than CH3COOH, in that case what happens is all of the acid will react. So your solution will only contain like salt and no acid. Right, so we have to find out the moles of CH3COOH and NaOH. So for option A, moles of CH3COOH, concentration times volume is 25 by 1000. It's 2.5 times 10 to the power minus 2. Moles of NaOH, 1 times 50 by 1000, 5 times 10 to the power minus 2. So in this case, obviously moles of NaOH is greater than the moles of CH3COH, so A can be eliminated. Option B, you have 50 centimeter cube of 1 mole per dm cube CH3COH. It will be concentration times volume. This is 5 times 10 to the power minus 2. If your moles of NaOH would be 2 times 2, concentration is 2, is 25 by 1000, which is the volume for this one. Gives you 5 times 10 to the power minus 2. In this case, NaOH and CH3COH both have the same number, same moles. Even if you have same moles, what happens is all of the CH3COH will react to form your salt, right? So in your final reaction mixture, you'll only have salt left, but there will be no acid. Question option C. In this case, let's find the moles of CH3COH. We have already done the calculation in the first part for 25 centimeter cube and 1 mole per dm cube, which is this. And we have moles of NaOH. This again 1 times 25 by 1000 gives you 2.5 times 10 to the power minus 2. Again, in this case, both the moles are equal, so all of the CH3COH will react to form NaOH. Now checking the last option, so we are just left with option D, so this has to be the right answer, but still let's try to solve this. Moles of CH3COH, this would be 50 times 50 by 1000 times 1, volume times concentration, 5 times 10 to the power minus 2, and you have moles of NaOH, which is 25 times 1 times 25 by 1000, 2.5 times 10 to the power minus 2. Obviously in this case, moles of ethanoic acid is more than the moles of NaOH, and that makes D the correct answer. Now moving on to question 28, we have to find the pair of species where Br has the same oxidation number. So in the first one, let's take Br as X, this as Y. Okay, so X plus 4 times minus 2 is minus 1, X minus 8 is minus 1, so X is plus 7. And for the other HBrO3 minus, so Y plus 1 plus 3 times minus 1 is equal to 0. So Y minus so it will be Y plus 1 plus 3 times minus 2 equals 0. Oxygen is negative 2. So Y plus 1 minus 6 is 0. So Y would be equal to plus 5. Plus 7 plus 5, E can be rejected. Second one, HBr and BrO2. For HBr, let's take it as X, this be as Y. So H is plus 1, so X plus 1 is 0, so X is minus 1. And for the BrO2, so 2Y plus 2 times minus 1 is equal to 0. So 2Y minus 2 is 0, so Y will be equal to 2 divided by 2, which is plus 1. Minus 1 plus 1 can also be rejected. Moving on to part C. This is X. So X plus 1 plus 2 times minus 2 equals 0. So X minus 3 is 0, so X is basically plus 3. And in Br minus, your Y oxidation number is negative 1. So this is for option C. Obviously it's also wrong, so D can only be our right answer, but we'll check the options for D. BrO minus, so X plus minus 2 equals minus 1, so X is equal to plus 1. So BrO minus, oxidation number of Br is plus 1. And for Y, Br2O, we already found out that in Br2O your oxidation number is plus 1. So plus 1 it's the same, so D is the right answer. Moving to the next one, we have to find out in which statement is correct for a voltaic cell, right? So in a voltaic cell, what happens is your electricity is produced, right? So chemical energy is converted to electrical energy. With this, we can eliminate option B, right? Now in any cell, we have this thing, anox and red cat. Okay, so reduction always occurs at the cathode, and oxidation always occurs at the anode, right? So from this, we can say that D is the right answer. In a voltaic cell, anode is your negative electrode, and at the anode, basically you have oxidation, so E can also be eliminated. Moving to 30, what are the major products for electrolysis for aqueous magnesium chloride? Okay, all right. So magnesium chloride, this forms Mg2 plus and Cl minus, and in water you have H plus and OH minus. These are the ions. So at the cathode, right, you can have these two reactions. Mg2 plus 2 electrons gives you Mg solid. So H plus can also form like hydrogen gas, but we write the equation in this way: 2H2O plus 2 electrons gives you H2 plus twice OH minus. and at the anode you will have these two reactions. You can have these two reactions. Twice Cl minus gives you Cl2 plus 2 electrons, or you can get twice H2O gives you O2 plus 4H plus this 4 electrons. Okay, now you have a dilute solution, right? It is a dilute solution. In a dilute solution you have a very big amount or very large amount of H2O, right? So what happens is, in this case, only your hydrogen, the reactions of water, reactions of H plus and OH minus will go through. As a result, H2 gas and O2 gas will be produced, which makes C as the right answer to question 30. Now, moving to question 31, this one is a good question. So here you have 1 mole per dm cube Fe2SO4 whole twice and CuSO4, they were electrolyzed, right? So we have to find out in which combination you will have the highest moles of product. Okay, so we have to find out the highest moles of products in for like which option will give you highest moles of products. That's it. So yes, so thing is Fe2SO4 whole thrice, here you have Fe3 plus ion. So one reaction will be Fe3 plus will react with 3 electrons to form Fe solid. Okay, so with this we can solve A and B. For option A, basically your moles of electrons will be total charge transfer divided by 96500. So you are passing 2 amperes of current for 45 minutes. So total charge will be 2 times 45 times 60, right? Divided by 96500. If I simplify this, if I just roughly simplify this, this should give me 90 times 6 divided by 9650. This should be 54 by 965. Right? Now if I want to find the moles of Fe, I can just take a stoichiometric ratio between Fe and electrons. So moles of Fe by moles of electrons. This will be 1 by 3. So moles of Fe will be moles of electrons times 1 by 3. 1 by 3 times moles of electrons, which is 54 by 965. 54 by 965, so 54 by 3 is 18, so 18 by 965. So in option A, 18 by 965 moles of Fe will be formed, right? Now let's quickly solve option B. Option B is also Fe, so moles of electrons will be current times time in seconds divided by 96500. So this is 36 divided by 96500, right? So moles of Fe, again by the stoichiometric ratio, we can say that moles of Fe is 1/3 the moles of electrons. 36 by 96500 gives you 12 by 00. So 18 by 12 by 965. Also be 965, it is 3600. 12 by 965. So obviously A has a bigger value, and eliminate option B. Now moving to the next two options, CuSO4. In CuSO4, your major reaction is Cu 2 plus 2 electrons gives you Cu solid, right? For option C, your moles of electrons will be equal to the moles of electrons of option A, same amount of current, same duration, 54 by 965. So here your moles of, I'll just use a different color, moles of Cu produced will be moles of electrons. So this ratio is 1 by 2, right? So it will be half times the moles of electrons. So this will be 27 divided by 965. I can also 26 by 965. So this is basically the highest value which we have found till now. I can eliminate option A. Now quickly we'll do option D. In option D, 1 and 61 current is 1 and duration is 60 minutes. So moles of electrons we can get, it will be the same as the moles of electrons for option B, which gives you 12 by 965. So moles of Cu will be, the ratio is 1 by 2. So half times 12 by 965. Not 12, this will be 36 by 965. This is 36. Yes. So it should give you 18 over 965, which is also smaller than option C. So hence option C is the right answer. Oh yes. Moving to the next question, we have to find out which compounds belong to the same homologous series. Alright. Same homologous series means you should have just that the difference between your elements should be CH2 only. Okay. And yeah, your functional group should be the same. So here these two are alkanes, but there is an alkene, So A is not the part of a same homologous series, right? So basically here the difference is plus CH2. Here the difference will be just of a carbon atom, right? So this is not a homologous series. So here this one difference is of CH2, fine. But if you check here from here to here, the difference is also of a CH2. Yes, this is an alkene and you're increasing the number of carbon chains. So answer should be option B. Option C is incorrect because there's an alcohol, there's an aldehyde, there's a carboxylic acid, different functional groups. There's an aldehyde, there's a ketone, there's an aldehyde. D is also wrong. So B will be the right answer. So for B, like if you want to check the options, you can also check the molecular formulas. So C3H6. Next one is C4H8. And the next one is 1, 2, 3, 4, 5. C5, and then the hydrogen will be 2, 3, 4, 4, 6 are 10, C5, H10. So in all the cases, you see that the increase is of plus CH2 only. So that's it about 32. 33, we have to write the name of this compound. So to find the name of this compound, what you have to do is we have to first identify the longest chain. The longest chain, I believe, should be this. This is your longest chain. Now we have to number it so that we get the lowest locants. So obviously numbering should start from here. So you have 1 chloro, 2 methyl, 5 carbon atoms is prop, all single bonds in, no functional groups present. So 1 chloro, 2 methyl propane, which gives B as the right answer. The next one, what is the organic compound when carboxylic acid and alcohol are heated together with concentrated sulfuric acid? So there is the ester formation reaction. So this has been removed from the latest syllabus, but here we'll solve it like this. This is your alcohol and this is your carboxylic acid. So these two, you'll remove the OH and hydrogen to form water, and then you'll connect this oxygen with this carbon to get the final answer. So this looks like CH3 COO CH3 whole twice. If you just flip it and write the formula, which exactly corresponds to option B, and B is the right answer in this case. 35. Which reaction will be the fastest? Now there are two types of reaction. First is like you have bromine and iodine. Remember, iodine, the carbon iodine bonds are weaker than that of carbon bromine bond. So any carbon iodine reaction will be faster than a carbon bromine reaction. So we can eliminate B and D. For option A, this is an SN1 reaction. While in option C, this is a 2-degree carbon, right? 2-degree carbon means there will be a combination of SN1 and SN2, right? So SN1 reactions are obviously faster compared to SN2, right? So we can say A is the right answer. Moving to question 36. Why are SN1 reactions best conducted using polar protic solvents? So basically in SN1 reactions, what happens? The carbocation is produced, right? So if you have like polar protic solvent, these solvent molecules will be able to stabilize the carbocation enough such that the nucleophile can come in and complete the reaction. So the answer will be option C. Carbocation is stabilized by solvent molecules. Now an option A is not correct. Carbocation is solvated. Forms a transition state with the negative charge? No, this happens for SN2 reactions. Nucleophile is ready to form a bond with the reactant. So generally the nucleophile is also solvated, but still like C is a better option as compared to D, because if nucleophile is solvated, what happens is it becomes stable, it will not attack. You can see nucleophile is not solvated as that much as compared to the carbocation. So C is the answer here. Moving on to question 37, we have to identify which structure is an E-isomer and which E-isomer in the easy system. Okay, so this has a priority 1, this has a priority 2, 1, 2. 2 ones on same side makes it Z. Yeah, 1, 2, 1, 2. Again, it's a Z. 1, 2. Chlorine and fluorine. Chlorine is 1, fluorine is 2. Chlorine has a bigger molecular mass. So for C, this is an E-isomer. Answer is C. And just check the last option too. 1, 2, 1, 2. Again, it's a Z. So option C is the right answer. Here, this one is only the E-isomer present. 38. We have 50 centimeter cube of sodium sodium hydroxide solution in NaOH, sodium hydroxide solution, which weighed 58 to 53.94 grams at 25 degrees Celsius. We have to find out the density of the solution. Density is mass over volume, so 53.894 divided by 50. Right? Thing is, in this case, your final answer should have three significant figures. Because while in the division case, you report your answer to the lowest number of significant figures. This one has 3 significant figures, this one has 5 significant figures. So we don't even have to solve it. You can say that only the answer with 3 significant figures will be our final answer, which is option A. Next part, which region of electromagnetic spectrum is used in H1 NMR spectroscopy, which is radio waves, something which we have to remember. Now the last question. What information do we only get from splitting pattern from H1 NMR spectrum? Number of hydrogens on the chemical environment. No, this doesn't give you like the particular number of hydrogen atoms will give you the the peaks, number of peaks, but not the splitting pattern. A is wrong, definitely. Number of hydrogen atom on the adjacent atom. Yes, B is the right answer. Number of hydrogen atoms on the adjacent carbon atoms will give you an idea about the splitting. And next one, different chemical environments for hydrogen, same as A. Ratio of, there's this, like the last option will give you the ratio of the sizes of the peaks. So for 40, option B is the right answer. With this, we are done with paper 1 chemistry HL of 2024 May attempt. I'll see you in the next video. Thank you.